In this tutorial, we will be discussing the strengths of acids and bases. So a strong acid is an acid that dissociates or ionizes completely in solution. So 100% of the chemical will break up into the H3O plus and whatever anion it is. Weak acids, however, only do it a little bit. So they break up, but then notice this backwards arrow is going back to its original setup. So it doesn't break up 100%. So in case you need a picture with that, we have originally hydroiodic acid. Once we put that in water, 100% of that is broken up. However much you put in to begin with is how much you have of the H3O and the I minus. Notice that none of the HIs are together anymore. There's only 6 of these that are considered common: hydroiodic, hydrobromic, perchloric, hydrochloric, sulfuric, and nitric. Weak acids, however, notice that when you put HF in water, the H and the F are still together at some points. So you'll get that H3O and F minus, but it's going to be far less than if it was a strong acid. Again, in a picture, the H's and F's are still together. The majority of these are weak acids. If you have a strong acid, it's going to have a weak conjugate base. What that means is once that hydrogen is given away, that iodine's not going to want it back. It's going to stay away. So it's going to produce a base, but it's going to be extremely weak and it won't want to take it back. Whereas, let's say we have bicarbonate ion. It has a hydrogen there it can give up. However, it doesn't really want to, and so it's very willing to take it back. So if it's a weak acid, it has a strong conjugate base, but if it's a strong acid, it'll have a weak conjugate base. If we want to look and examine this in a jar, notice that this is HCl. Both of these are 1 molar solutions. There is no H and Cl together here. All the H's have been absorbed by the water. Over here, however, the acetic acid is still together in as a molecule in several instances. So the H3O plus only happens occasionally here. Finally, strong bases, how do you know them? If you look at the periodic table, the first 2 rows, groups 1A and 2A, that is where your strong bases are going to come from. They're going to be OHs of those. So lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, those are considered strong bases because they break up when they're in water and they can neutralize that acid. These, once again, dissociate. They break up completely when they're in the water. Notice that there's no backwards arrow. It only goes in one direction. And that's your overview of strong acids and bases.